So, what if you could ask a question and get an answer from the entire world's connected data? Well, there's a powerful language designed for exactly that, and it's called SPARQL. We're going to see how you can use it to retrieve and, more importantly, integrate data from all over the internet with just a single structured query.
Okay, so here's our game plan. First, we'll look at the big picture, this idea of a web of connected data. Then we'll learn its language, which is all about something called RDF triples. After that, we'll break down a SPARQL query piece by piece, run our first one, and finally see where its real mind-blowing power comes into play. Right, so before we get into any code, let's talk about why SPARQL even exists. What problem is it trying to solve? Well, it really just boils down to one huge challenge. How do you integrate information when it's coming from all kinds of different places? And this right here is a perfect example. Think about it. Instead of just having a folder of documents about Microsoft and another one for LinkedIn, a knowledge graph creates a web of data. That means the relationship itself, like this person works at Microsoft and also have a LinkedIn profile, becomes a piece of data you can query. It's the connections that matter. And the scale of this is, well, it's absolutely massive. Thanks to things like the Linked Open Data Initiative, we're talking about over 25 billion individual pieces of information, all publicly available. You can connect drug data from one database to protein data in another. It's this giant interconnected resource just waiting for someone like you to come along and ask it a question. So how do we talk to this giant web of data? Well, first, you got to understand its fundamental structure. Everything, and I mean everything, is built on this really simple but super powerful format called the RDF triple. The best way to think of a triple is as the basic atom of meaning for the web of data. Every single fact, no matter how complex it seems, gets broken down into these simple three-part sentences. You have a subject, a predicate, and an object. That's it. Christoph owns Victor. Simple as that. And here's what that looks like in the wild. This little block of text describes a person and his cats. Each statement is a triple. So the subject, #Curtibrew, has the predicate as and the object foa person. That little semicolon just lets us keep adding facts about the same subject, like he also owns #Victor. We're literally building a tiny graph of knowledge, one simple statement at a time. Okay, so we've got the data structure down pat. We know it's all just a bunch of simple triples. Now, how do we actually ask it questions? Well, that's where SPARQL comes in. Here's the most important takeaway. If RDF triples are the database, then SPARQL is the language you use to talk to it. It is the standard. It's for the web of data what SQL is for traditional databases. It's how we ask our questions. Now, every basic SPARQL query has a really clear and predictable structure. First up, you've got prefixes. They're just shortcuts so you don't have to type out long web addresses over and over. Then the result clause, usually select, is where you say what you want back. The dataset clause tells it which data you're looking at. The pattern, that's the where clause, is the real heart of the query. It's the puzzle you're asking it to solve. And finally, modifiers let you do things like sort your results or just get the top 10. All right, enough theory. Let's actually put this structure to work. We're going to write our very first query using that cat example from before, and we'll pull out some specific info. So here it is. Our question is, find all the cats and their names. We tell the system to select two variables. You can tell they're variables because the question mark. We'll call them !cat and !name. Then in the where clause, we lay out our pattern. We're looking for anything that is a type of cat, and we're also looking for the name of that same thing. And boom, just like that, the SPARQL engine scans the data, finds all the triples that perfectly match our pattern, and hands us back the results in a nice, clean table. It found every single cat and pulled out its name. It worked. Okay, cool. But let's scale this up a bit. What happens if we run a really simple query on a huge public data set, like DBpedia, which is basically the data version of Wikipedia? Let's just ask it for 50 things that have a name. Seems simple enough, right? What do you think is going to happen? We get a ton of duplicates. Why? Because a single thing, like a person or a city, can have lots of different names stored in the database, maybe names in different languages. Our simple query just grabs a row for every single name triple it finds. It's a great lesson that you have to be precise with your questions, though, of course, SPARQL has ways to clean this up. But this is where SPARQL really shines. It's not just about asking questions of a single dataset. Its true power is in integrating data from multiple sources, all in one go. And the magic word is service. This keyword lets your query literally jump across the internet to a totally different database, what we call a SPARQL endpoint, run a query over there, and then bring the results back to seamlessly combine them with your local data. I mean, that is incredibly powerful. And look, you're not on your own here. This isn't some niche academic thing. SPARQL is supported by a really mature, robust ecosystem. You've got powerful open source databases called triple stores, plus all kinds of programming frameworks that are ready for you to build real-world applications today. And it's not always about getting back a big table of data. SPARQL also has an ask query. This is for when you just need a simple yes or no answer. So instead of show me all the cat owners, you can just ask, hey, are there any cat owners in this data? It's super efficient for quick checks and validation. So, what's the big picture here? Let's recap. The world's data is becoming a giant, connected graph built on simple RDF triples. SPARQL is our standard language for asking questions of that graph. A basic query has a clear 5-part structure. And maybe most importantly, federated queries let you pull in and combine data from all across the web. We've just given you the fundamental tool to retrieve and integrate information from this incredible global graph of data. The next step is really up to you. Get out there, explore the data, and start asking questions. What insights will you uncover?